my name is Johnny Bannon, and I will be your CCNA instructor for this CCNA video series. In this video, we're going to continue with our QoS learning and lesson and go over queuing now. So now that we've learned how to classify and mark our traffic, why we need QoS, let's get into what we do with those classifications. We didn't group that traffic for no reason, right? We need to do something about those groupings or do something with those groupings. So the first thing we're going to talk about is queuing. So again, important to remember that the whole point of QoS is if there's congestion, how do we handle it? Well, one thing we do is we can place traffic into what we call a queue, essentially a buffer that says, okay, these packets, there's no available bandwidth to send these packets, but instead of dropping them, we're going to queue them in our router and really in that physical interface there so that we can prepare to send them. So we call that queuing. And there's a lot of different methods we can do for queuing. So why these packets wait to get forwarded? How do we decide which ones are next? So there's some things we need to know about as far as queuing goes, something called tail drop. So if the queue becomes full, that means we have packets that are filling up, waiting to be sent, and all of a sudden we reach our threshold because that buffer is beholden to the hardware, right? And if we can only hold, let's say, 10 megabits in our queue, that's the only buffer we have on our physical interface, then if that gets full, we have something called tail drop, where those packets are going to get dropped. And then now that user that may be waiting for return traffic is like, okay, well, let me resend. So that computer is going to just keep resending, let's say, that HTTP traffic, essentially giving us that a recurring issue of, okay, these packets we keep filling, keep getting dropped, and nothing's really getting fixed. We call that tail dropping. So what we have is some technologies called random early detection or weighted random early detection that's going to allow us to detect a queue getting filled up prior to it just being dropped. And it's going to allow us to just drop those packets before the queue actually fully fills up. And that's going to avoid what we call that tail drop. And that tail drop, again, it's important because that enables kind of like this reoccurring looping issue where the sender of that traffic is just going to keep sending, right? So if we can avoid that tail drop with some early detection, kind of sending a message back saying, hey, we're full, then the ingress traffic that we're getting here won't get set to the egress to fill up its queue and keep having that tail drop. So another thing with queuing, just because somebody waits in a line doesn't mean they know when they're next, right? Unless we have someone there directing it. So with queuing, we have something called scheduling or a scheduler. So with queuing, we can create multiple different queues based off data classification, which we're going to get into. And then we have to have some sort of schedule. Because if these packets are all in a queue, which one comes first? If I've classified email and I've given it its own queue, doing some like class-based weighted fair queuing, what's the deal, right? How do I know which one goes next? So with regular queuing, just fair queuing, we have something called round robin, which means that the order that the packets were placed in the queue is the order they're going to get transmitted. So there really is no system to it. The schedule pretty much just says, okay, who's next, right? But with weighted, what's going to happen is we're going to have the ability to actually have that schedule be a little, that schedule or scheduler be a little bit more smart with the priorities. So this could be how we classified it, right? If we gave some traffic that higher DSCP value or that EF value bit, the scheduler can see that it's weighted, saying, whoa, okay, this traffic, we're going to send more data from this queue for this traffic than we would other traffic. And what we mean by sending more data is just because maybe this email traffic has a higher priority doesn't mean we're going to completely empty the queue and forego the rest of these, saying, sorry, better luck next time. Essentially, what that means is we're just going to take bigger data chunks from this queue than we would, let's say, this queue down here. So with this one, we may take 8 bits at a time, where with this queue down here, we only take 2 bits. That's weighted. And then class-based weighted fair queuing is when you do it based off these classifications here, right? So we're going to build these different queues, essentially these lines, these queues. We're going to have them fill based on their data classification. So this is kind of another way to see the flow of QoS, which is pretty cool. What we can see here is that first we classify and mark our data. So we did that. We decided to only have 4: email, voice, and video. And then what's this default? Something we haven't talked about yet. That's everything else. That's anything you don't classify or specify or mark further. This is any traffic that isn't going to be marked or classified, essentially. It's going to be classified into what we call the default class. So with no queuing or no QoS involved at all traffic belongs to default. But when we say, hey, mark all email traffic or match the protocol email and give it a higher priority, that becomes part of that email class. And then if we just did email and we didn't have these voice, video, or anything else, any other traffic that was an email would go to the default. So that's the default class. But back to this flow, right? So you can see the flow of QoS here. First, we classify. We could do this with some markings if we want. Then we tell it how we want it to be queued. So we say, okay, look, if you're the email class, we want to give you, let's say, 40% of the queue. Voice, we want to give you 20% of the queue. Video, 30%. And then default, you get the rest, which would be 10%. Whatever the case may be, right? And this would be something called class-based weighted fair queuing. Class-based weighted fair queuing. And then in that scheduler, since it's weighted, right? That W, since it's weighted, we're going to say, okay, I see that this email class is obviously higher priority because you're assigning it a bigger queue. I'm going to take more data from here. And then my next queue I go to, I see the voice is lesser priority. So I'm only going to take a little bit of data. Pretty cool, right? And then we decide how we want to shape or police these queues. So maybe we say, hey, email traffic, we still want you to have 2 megs no matter what. So what's the issue? That's the shaping. And this is like the flow of QoS, right? Classify, queue, transmission, or shaping and policing. So what is the issue here? Well, if this email and IM traffic is so important, it's such a high priority to make business happen, to enable the business, right? We're not emptying that queue. We're just taking a little bit more from it. We still have packets waiting to get forwarded. And if this is the highest priority traffic we have, we need the traffic now. Class-based weighted fair queuing just ain't going to cut it. So we have something called low latency queuing, where if we assign this classification of traffic to LLQ, we're telling the scheduler, hey, you need to empty this queue out fully before you even start doing some round robin or weighted action down here. So you can kind of combine these, where one classification of traffic could be LLQ, and then the rest of these are class-based weighted fair queuing. And that scheduler is going to make sure that your low latency queue is completely empty before it starts scheduling other traffic to be forwarded in your class-based weighted fair queue. So then what's the issue with this? Well, if this queue is constantly filling up, it's always on excess, this traffic's never going to get sent. And then we start getting that tail drop because these queues are constantly full. So again, you kind of got to add something else to this. That's where we get into shaping and policing, where we say, hey, maybe, yes, you're part of that low latency queuing, but we're going to police you. You cannot take up more than 4 megabits of our 10 megabit link to allow these queues to also send their traffic. So kind of this intricate system of QoS you're kind of seeing now, right? As we get further into the QoS tools we have. Okay, and then let's go over the individual slides for the queuing methods. So FIFO, this is where there really is no queuing. It's first come, first serve, or first in, first out. So traffic comes in, it goes out in the order that it's received. weighted fair queuing. So this is going to give that fair allocation to different types of traffic. So with weighted fair queuing, essentially what we're doing is we create that queuing buffer. This isn't based on any classes. It's just going to say, okay, these 2 megabits came in, put it in this queue. These 2 megabits came in, put it in this queue, and give it your own kind of priority, right? And we're going to weight it out. So this high, we're going to take a little bit more data from you. But then when we move on to medium, we're going to take a little bit less data, and we're taking a little bit less data here. Whatever the case may be, right? It's weighted fair queuing that provides that fair bandwidth allocation. And then we have class-based weighted fair queuing, where we're going to create these different queue buffers that we define. So we classified our traffic. So maybe this is AF43, this is AF32, this is AF11. And with the weighted fair queuing, it's still going to have that mechanism where we decide, okay, this traffic is higher priority, so we're going to take more. This is second highest, so we're going to take a little less. This is third highest, so we're going to take the least amount from these queues. But it doesn't actually empty anything out, right? And this is different than weighted fair queuing because instead of the queuing method just doing this kind of on its own, it goes off the classes we define. So in the CLI, you put this. You're going to put that we want to give certain requirements to the traffic we match with AF41. We want to give it a higher priority as far as the queues go, as far as that scheduling of queue traffic to be forwarded. And then low latency queuing. This is that strict priority queuing, okay? So what this does is it gives you a priority queue of a class that you're going to always send first out of all these queues. And this queue needs to be emptied before we moved on. But of course, like I said, we could add some policing methods where we say, okay, look, we have this priority queue that always need to be empty, and we're always going to be sending traffic from this queue on a consistent basis, but we're going to rate limit you to only get 500 kilobits as the minimum, and then 4 megabits as the max. So this other queues down here, these are classes that we define. We still want to give them the ability to actually get sent out. But as we send out, yes, you will always have priority. You will always have this amount. Okay? If we don't put that policing on there, we could have that issue where this queue is just only getting this traffic sent and preventing the others. Okay, and then let's go over shaping and policing. So traffic shaping, what this is going to do is actually retain any excess packets in a queue, and then it's going to schedule the access for later transmission. So what we mean by this is essentially like when we have that priority queue, this is going to say, okay, well, we're going to shape you to make sure that you're consistently getting sent, but if you kind of go meet that threshold, we're not going to drop you. We're just going to put you back in the queue. So we kind of have this even traffic rate. Whereas policing isn't so forgiving. What traffic policing does is it's going to allow burst. Essentially what this is saying is, hey, what we're going to do here is we're going to let you have 4 megabits. And we're always going to let you have 4 megabits. So at sometimes you may only do 50 kilobits at a time, but when it's needed, we're going to max you out at 4 and give you that high transmission rate. You may ask, well, how does this differ? Well, we're shaping, what we're saying is always send at this traffic level, no matter what. So if we shape it to 1 meg, if we don't have 1 meg to send, that's fine. We're still going to give that 1 meg availability. But if we're going over 1 meg, instead of dropping traffic, we're just going to put it back in the queue nice and gently. With policing, we're going to be like, okay, you're not sending the max 4 megs. That's fine. You don't have to. Send down here, right? But as soon as you need that burst, we're going to allow you up to that 4 megs. But the moment you try to pass that 4 meg threshold, you're getting dropped, buddy. So policing isn't as forgiving. It drops traffic if it tries to go over its rate limiting or that policing. All right, now let's go over the modular QoS Cisco CLI. So now we're going to go over how to actually configure. So if we go through our QoS flow again, what's the first step, right? And this is after we've done our planning. We're going to classify and mark traffic. Then we're going to queue it. And then transmission, we're going to either shape it or police the traffic. Those are our steps. So now let's go through these steps in the module QoS CLI. So the first thing we're going to do is either create an ACL, this is an if, we don't have to match based off a subnet. So this is going to be our part of our classification step. So if we want to classify traffic just based on a subnet, we can. And then that class map, we can say match an ACL. Or in this class map, we can match a protocol. Or we can match based off DHCP. So what this means is, like, if we're the second router here, and router 1 sending us traffic marked, right? We can see that. We're like, okay, we see that we're getting traffic with the AF41. So we're going to match that traffic and send it to this policy map. And then this policy map is going to decide what you do. So this is going to be where we decide what kind of queuing and how we shape or police that traffic. And this is going to be based off class maps. So kind of the flow is we create a class map that matches our traffic, however we want to match it, either based off a whole subnet as defined by an ACL, match it based off a protocol, or match it based off some markings in the IP header. And then when we create our policy map, we're going to say, hey, when you're dealing with traffic in this class, I need you to queue it this way, shape it this way, or give it this much bandwidth, right? So shaping and policing. And then that policy map still ain't doing shit until we apply it to an actual physical interface, either inbound or outbound. So either ingress, what are we going to do with ingress traffic? Or how are we going to shape and manipulate and do QoS on traffic leaving? Typically egress we're going to see. And we apply that service policy to an actual interface. So now let's go over some syntax. So the class map, here you can see we have two different ways. We can do match all or match any. And the difference between this is saying match all, the difference between all and any is all is going to say match all traffic coming through. Match any is going to be a little bit more specific, saying match any of this protocol. It kind of gets a little hard to understand, right? But the default class map function is to do match any. So if we actually go to our CLI, let me bring it up. So enable, we can do class map, and then we can do match all or match any. So this could be match any statement under this class map. We can do match any, which means logical or all matching statements under this class map, okay? So this kind of goes to the and or logic, where all means, hey, we're going to allow you to match anything that we put under here when you configure your policy map. Match any is essentially saying it's going to be or. So under that policy map, maybe you can only set policies for one of the classes I put in this class map, right? It's kind of that difference between that and or logic. And the default class map behavior, I'm pretty sure is match all, but let me look it up real quick. Default class map behavior, because I don't want you watching this video and getting the wrong information. But yeah, default is match all, okay? So yeah, the default is match all. So again, kind of going through the differences in these is with match any one line has to match for the match to occur. But in match all the lines have to match for the match to occur, right? So kind of goes through the logic of it too, where if I have this class map, and let's do this in syntax. The default behavior, this is just a name, is match protocol. Let's say match access group an ACL 10 and 20. That means if we want to classify traffic, the traffic that we classify under this class map has to match both of these ACLs. So if it only matches one of these ACLs, then we're not going to actually apply anything to this, and this is a bad class, right? Or essentially saying that if this ACL wants us to match 1.1.1.0/24 traffic, and this one wants us to match 1.2-0/24 traffic, this class map's never going to work, because never are you going to have a scenario where source-based traffic that you're applying like QoS to can have two source-based IP addresses, right? So it ain't going to work. Now, if we had an extended ACL we're matching, this could work, because with those extended ACLs, we could say 1.1.0 traffic equal to 23 and 1.1.0 traffic equal to 22. So this may work in like the packet flow of like, okay, this user is sending traffic here and here, so we can put them in this class map, right? So with match any, they only have to match one to be able to be part of this class. Now, this kind of never really comes into play, and let me explain why. Because when we do this class map, we name it HTTP, typically we only want to match it off one thing anyways, whether that be an ACL in the source IP addresses subnet or just one precedence, right? We just want it to match off precedence CS1 or critical, or we just want it to match. So like if I want to change this, I would say no. And if I just wanted to match under one protocol, that's all I would do. And then if I wanted to match traffic for HTTPS, I would just make a whole new class map, right? And I would do match protocol HTTPS. Or let's see, what is HTTPS? Maybe like www or something like that. Let's see here. Again, this really, and this does depend on like, this does depend on your iOS version, what options it gets you for the protocol. Pretty sure maybe it's SSL, but there's a way to do HTTPS here. But anyways, you get my point. If you wanted to match different traffic, you would just make more class maps. You wouldn't try to do a match any or a match all classification. And if you were doing match all, you really can only do one match, right? Because again, a single TCP flow isn't going to have more than one marking or more than one protocol on it. So again, kind of going into the logic there. This is going to mess me up. I'm definitely going to have to look it up how to do match HTTPS. But that's okay. So that's how the class map works. Okay, then the policy map. So the policy map is where we're going to decide how to queue or shape or police the traffic that we classified. So right here, we see we made a policy map called HTTP traffic. We're going to decide what to do with our classification of the HTTP traffic, and we're going to give it bandwidth 200,000 kilobits. So we're shaping that traffic to say kilobits. Policy map IM traffic, and then our class map was Skype. We're going to do some rate limiting on this. So this is policing. So we're going to say, hey, police committed information rate 10 kilobits, and then transmit. So if you're doing 10 kilobits, we're saying you can transmit. And we could have done a range here too. We could have done another command like to give it 2 megabits. But there's so many different options we can do with this. I mean, the thing is about QoS, like I was saying earlier, It all depends on what your requirements are. So if you're going to want to make sure HTTP traffic has high priority, maybe you can set that bandwidth. And what that does is, excuse me, I said shape. What that does is going to set it as part of that LOQ, right? Saying, no, 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 this is getting this bandwidth no matter what, right? Or you could say priority. So that strict scheduling priority, where if I type in priority underneath like one of my policy maps, let me bring this in here. This is going to do that LOQ as well, saying priority percent. We're getting 25% of that bandwidth no matter what. And maybe we want to do random early detect, right? Based off, DCP parameters. So if you're 41, we want to do that random early detect where we say, hey, this is how many bytes, right? That's going to be the threshold in that queue. So there's so many different options we can do, and that's why for the CCNA exam, we just want to keep it simple, right? Like when we do our lab, essentially I'm just going to have you guys configure fair queue, configure a bandwidth percentage, and then move on. Apply it to an interface, and then say, oh, cool, That's really all we're going to do. All right, then service policies. This is where we actually start to apply. So now we're actually going to apply that traffic either inbound or outbound. So now output, if we're doing policing or shaping or setting that strict priority, now we're telling it, okay, we are going to, on the egress, this policy map HTTP traffic, we're going to do that policing or that rate limiting or giving it that priority queue. So you got to apply that policy map, and you're doing the policy map name, or this service policy is what it's called, underneath an actual interface. Okay, so that's going to be it. So this is going to wrap up our QoS lecture. Again, QoS can be so in-depth, and I hope I kept it under at least an hour and a half, because QoS can be a lot longer, trust me. In our next video, we're going to go over our QoS lab. It's going to be something simple, right? I'm just going to have you go through the flow of creating an ACL, putting it in a class map, matching that ACL, then making a policy map saying, hey, any of this traffic, give it 25% bandwidth. And then we'll make another ACL, put it in the class map, and then we'll mark it with an AF bit 31, do a quick Wireshark capture, and that'll be it, right? We'll see us placing that IP bit, IP precedence, or DHCP bit. We'll see it getting our bandwidth, and I'll do some show commands so we can actually look at the policy to be like, oh, okay, that is getting the bandwidth, or we are doing that queuing there. So with that being said, I want to thank you for viewing, and then stay tuned for that lab.